All right, so on this lesson, we are going to finish up our notes on lesson 2.6. So the previous lesson, we talked about vertical and horizontal asymptotes and holes in the graph. We took a minute and talked a little bit about x-intercepts and zeros, but we didn't really do anything with that, so we are going to do some more of those today. And then I'm going to introduce you to a new asymptote that occurs occasionally. So if the degree of the numerator is exactly one more than the degree of the denominator, there is a slant asymptote. Okay, and to find the slant asymptote, you must divide. So you're dividing the numerator by the denominator. Sometimes you can do synthetic division and sometimes you can't. So sometimes we will have to do long divisions. Depends on what your denominator is. All right, so on example 2, we're going to find the slant asymptote. So first let's just double check that there is one. So we look at the degree of the numerator and we look at the degree of the denominator. The degree of the numerator is 3 and the denominator is 2. 3 is exactly one more than 2, so there is a slant asymptote. So what we'll do is take the numerator and divide it by the denominator. Now, we cannot do synthetic division on this one because our denominator has an x squared, not just an x. So we are going to have to take the numerator, put it in the box. Now, I'm going to go ahead and add 0x squared plus 0x plus 0 to help us keep our like terms lined up. All right. And then when I divide, I ask myself, what do I multiply x squared by to get x? And that is x squared by to get x cubed, and that is going to be x. Right? And then I will multiply. And then I will subtract. All right, so 0 plus x is x, and I write down 0, which I don't really need. So if I go to divide again, and I ask myself, what do I multiply x squared by to get x? X squared is too big to become x. So this is our remainder. So we would do plus x over x squared minus 1. Now, one thing I want you guys to know about slant asymptotes is we do not need the remainder. So we just always just mark off the remainder. We don't need it. So your slant asymptote is the line y equals x. So y equals whatever there is before the remainder. Or it's really just the quotient part without the remainder. Okay, let's look at the next one. When we look at the degree of the numerator is 2. The degree of the denominator is 1. 2 is exactly one more than 1, so I can divide. This one, I can do synthetic division because my denominator is x minus 2, so I put 2 in the box and then bring over my coefficients and my constant. Bring down that 2 and then multiply and add, multiply and add. Now don't forget that when we are finding slant asymptotes, we do not need the remainder, not at all. So this time, our slant asymptote is the line y equals 2x minus 1. Okay. So on this assignment, or on this, we're going to find a domain, holes, asymptotes, intercepts, and do the graph. So like every single thing there could possibly be. So just a reminder from day 1, the x-intercepts are the zeros of the reduced numerator. So remember when we did this problem, this factor here that was in the numerator outside of the box gave us our x-intercept. That's what we're going to do for that today. All right, your first step is still to factor. And when we find the domain, we do it before we cancel, before we box anything. We just look at our denominator. Anything that would make those factors 0 is not in the domain. So there's two things x cannot equal. So what that means is that they make the function undefined. And when the function is undefined, it either has a vertical asymptote or it has a hole at that value. Okay, so I'm going to box off what they have in common. The vertical asymptote comes from the denominator. What's outside the box in the denominator is going to create the asymptote. What's inside the box in the denominator, that's where there's a hole. And then to find the y part of the hole, we take that -2 and we plug it in for the x after we cancel out. So that's going to give you 0. That's where the hole is. Okay, so let's talk about the horizontal asymptote. So we look at the degrees of the numerator and the denominator. They are equal. When they're equal, we do the leading coefficient of the numerator over the leading coefficient of the denominator. Now, one thing that can help you kind of save some time is that if there is a horizontal asymptote, there cannot be a slant asymptote. So we can automatically say none. Because remember, for there to be a slant asymptote, the numerator is exactly 1 more than the denominator. When that happens, there is no horizontal. Okay, so let's go to, I'm running out of colors. Let's go to the x-intercept. So the x-intercept, we look at the numerator, what is not in the box. Whatever makes that 0 is an x-intercept. So that's the point -2, 0. Is that another point that we've already talked about? Sometimes this happens. This is actually also the hole. So if there's a hole right there at the x-intercept, that means there's really no x-intercept. The hole can't intercept it because there's actually not a point there. The y-intercept is fairly simple to find. So the y-intercept, or it should be sept, is the value of the function when x is equal to 0, f of 0. So we would take our original function and make all of the x's 0. Now, when you make all of the x's 0, anything that has an x becomes 0, and you're just left with 4/6, or 2/3. Okay, so let's graph all these things. We have a bunch of fractions here. So what I decided to do, because I have a pretty big grid, is just go by 1/2. So I'm going to put my x-axis here. And I'll put my y-axis here. And then I'm going to skip every other grid mark to label. So I'm going to go by, basically going by 1/2. And I would do it the other way too. I didn't want to do that, sorry. Okay, so let's go graph our vertical asymptote. I'm going to color code mine So vertical asymptote is at -3/2, so that is at -1.5, which would be right here. And when we graph asymptotes, we graph them as dashed lines. So we have a dashed vertical line when x is equal to -3/2 or -1.5. All right, and then I have a hole in the graph at the point -2, 0. Okay, and I have a horizontal asymptote when y is equal to 1/2, which would be right here. So remember, asymptotes are dashed lines in your graph. Okay, now this one, the only place that it's kind of on the x-axis is at that hole. And then we cross the y-axis at 2/3. So 2/3 is going to be between 1 and 1/2. So we'll say it's about right there. All right, now I want to get a little bit of a better graph. So what I'm going to do is do a little table of values. So I'm going to plug in -3 because it's on the left side of my hole. And then in between my y-intercept and my vertical asymptote, I have -1. I'm going to plug in. All right, and it's okay when we plug them in if we plug them into the reduced version. So I could do like I did for the whole. So -3 plus 2 over 2 times -3 plus 3. So I'm going to get -1 over -3 or 1/3. So I have a point at -3, 1/3. Right, and then I can do the same thing for -1. And that looks like I get 1 on the numerator and 1 in the denominator. So that would just be 1. So I have a point at -1, 1. All right, so don't forget that asymptotes are lines that the graph approaches. So this one, I'm going to be close to the horizontal asymptote. I'm going to curve through the point, I'm going to curve through the hole, and then I'm going to go close to the vertical asymptote. And then same thing here, I'm going to start close to the vertical. I'm going to curve through my points, and then I'm going to finish close to the horizontal. That's how you graph a rational function. All right, we're going to do one more. This one's going to take a minute to do the factoring part. So that numerator, we're going to factor by grouping. We're not done with that, but I'm going to go ahead and factor my denominator also. All right, so on my numerator, they both have an x plus 2. So what I factored out is one of my factors, and then that x plus 2x, I think I said that wrong, 2x plus 1 is my other factor. So right now it looks like nothing will cancel, and that's possible, but the x squared minus 4 is difference of squares that will factor again. So this right here is my final oh my goodness, sorry. All right, this is my final factorization. So when I go to do my domain, I look at my denominator, any x value that's going to give you 0 in the denominator is not in the domain because they are going to you are either going to have a hole there or you're going to have a vertical asymptote there. So you can start thinking about whether or not they're going to be a hole or a vertical asymptote at those points. We'll start with the vertical asymptote. So the vertical asymptote comes from the factor that is in the denominator outside of the box. So that's going to be the equation y equals 1. The whole comes from what's inside the box. So that's going to be the 2 part. Right? And then if I cancel that out, I plug 2 in. And I end up with the whole is all the way up at 20. 220. That's why I gave you such a tall grid. All right, then our horizontal asymptote. We're looking at the degree of the numerator and the degree of the denominator. We have 3 on the numerator, we have 2 in the denominator. When the numerator degree is larger than the denominator, there is no horizontal asymptote, which was nice, but now that means that there could possibly be a slant asymptote. If there's a slant, that means numerator is exactly 1 more than the denominator, and that is exactly what we have here. So we're going to have to take that numerator and divide it by the denominator. And with a denominator like that, a function like that in the denominator, you do have to do long division. So you ask yourself, what do you multiply x squared by to get x cubed? And that's going to be 2x. And then you multiply. Then we have to distribute it to 3 places. And then you subtract by changing all 3 of those signs. And then you bring down, and then you start all over with your division. So you ask yourself, what do you multiply x squared by to get 7x squared? And that's going to be 7. And then we can stop because what the further we would go, it would just be to get the remainder. We don't care about the remainder on the slant asymptote. So your slant asymptote is the line y equals 2x plus 7. Okay. We also are going to find the x-intercept, and there could be more than one. So when we're looking at the x-intercept, we're looking at this one in the box here, and we're looking at the numerator not in the box. All right, so we have 2 factors here. We have x plus 2 and 2x plus 1. Both of those are going to give us x-intercepts. So your x-intercepts are going to be at -2, 0, and at -1/2, 0. All right, and then for your y-intercept, I always go back to the original function. Anything that has an x becomes 0, so basically it's covered up. We're left with -4 over 2, or -2. So 0, -2 is your y-intercept. All right, so we're going to graph all the things. There's a lot of them. Okay, so I'm just gonna kind of go right down the middle on my y-axis, but my x-axis I am not. So I'm going to go up 8 from the bottom. 1, 2, 3. And I'm going to draw my x-axis. I only know this because I've already done this one. And I know I have to get up to 20, so I counted appropriately to make sure I got to 20. And then I'm just going to label, I'm going to count by 5. I'm just going to label every 5th grid. There we go. Now, let's go ahead and put all the things on there. So we're going to start with the vertical asymptote at x equals 1. I'm doing a dashed vertical line when x is equal to 1. Okay. Then I have a hole at the point 220. It's right there. I'll make it a little bit better. Right. And then I have no horizontal asymptote. I do have a slant asymptote that's at the line y equals 2x plus 7. So I'm just going to graph that line. So I go to a y-intercept of 7. And a slope of 2 means up 2, right 1, up 2, right 1, up 2, right 1. So these dots, let me do that a little bit better. Those dots are going to make my slant asymptote. So I can also go down to left 1. There it is. All right. I have 2 x-intercepts. I have one at -2, 0, and one at -1/2, 0. And then I have a y-intercept at 0, -2. All right. I feel like that's enough for me to be able to do this graph down here. So I'm going to be close to the slant asymptote. I'm going to curve through those points. End up close to the vertical asymptote. And then I will have a similar shape up here. So close, curve through the hole, end up close. Now that's kind of a weird graph, but that's what we got. All right, so this assignment is building on stuff you did yesterday. So on page 77, we're going to do B and D on number 28, 30, and 35 from the previous assignment. And so we've already done the domain, the asymptotes and the holes on those. So you'll have to go and do the intercepts. If there's a slant asymptote, find it, and then the graph. And then I want you to do all of number 59. So you haven't started that one yet.